Okay? Here's what you want to do. First of all, take the derivative. Okay? We've done the derivative of an exponential function numerous times. The derivative of an exponential function is what? Keep it the same times natural log of the base. By the way, what's natural log of e? 1. Okay. What's the last thing you do?
Chain rule of the.
Chain rule of the exponent, whatever has the x in it, right? What is the derivative of negative 2 sine of x? Cosine of x. And technically, there is a second chain because that little x right there produces
A one.
a times 1. Don't have to worry about it. Okay? And there's your derivative.
Would you put that in front?
You could. It won't matter. Either place. But yeah, that's a coefficient, so that should go first. And then the original function should go last, so yeah.
Equals 0.
And set it equal to 0 because we're finding the roots of the first derivative. Okay? Never done that before, but actually we have. Believe it or not. In pieces we have. We said something very important about e in this chapter that I want you to never forget. And that is e to any power is,
Always increasing, or always above.
it's always above the x-axis. Isn't e like this?
Yeah.
Or if it's an
Negative.
e coming in for the landing, isn't it still always above the x-axis? Doesn't matter where you go. So exponential functions are always positive. They can't be 0, they can't be negative. But what about e to the 0? It's 1. Still can't get 0. You can't get 0. So this exponential right here, that we talked about the other day, is not equal to 0, so that's off the table already. Don't even have to worry about it. Okay? And let me siphon this one off. You want to guess that one? Okay? Let me siphon this one off.
Yeah.
Negative 2 can't be
0.
0 either. It all boils down to cosine. That's it. So all you have to do is tell me where cosine of x equals 0. I.e. where the cosine graph has what's? What are the roots anyway? Graphically, what are the roots?
Pi over 2.
Okay, sure, but they're all the, yeah, sure, but it's like charades. Sounds like,
Pi
okay,
over 2.
but roots
Pi
or,
over 2.
yeah, I know that, but, yeah, they're graphically, graphically, they're all the x-intercepts.
How are we supposed to do
Okay?
that?
Well, somebody would catch me. But anyways, roots and zeros are x-intercepts. That's all they are. So you're basically saying, where are the x-intercepts? And of course, as you clever kids all knew, it's all the half-pies. Okay? And we did a whole section on this back in the first semester, where it's like cosine of blank equals 0. What's blank? Okay? Cosine of pi equals 0. Cosine of 3 pi over 2. Or sorry, pi over 2. 3 pi over 2 equals 0. Blah, blah, blah. Oops. What does that parentheses mean right there?
Not including.
Exclusive, so it is not including, is it? So pi over 2 just barely missed the cut, and everything after that would be too big. What about negative pi over 2? Is that okay? Negative pi over 2 fits. The next x-intercept would be negative 3 pi over 2, but
Too much.
too low. So you only get that one answer. Interesting problem. So it's a little bit of first semester. It's the old classic cosine graph, which you should never forget. It's it could be the sine graph on
So
the
you
test.
don't have to do a first derivative test.
Right. You just want to see where are the zeros. Okay. All right. And that's always positive, and that's actually always negative because it's negative 2. So you just eliminate to what's important and forget about the rest. Okay. Interesting problem. And by the way, these critical numbers here, you don't have to do a first derivative test, but they would all actually be sign changers. They would not be false readings. So they would all be extrema. You know why I know they're all extrema?
Because it goes up and down.
They are above, below. They're changing above and below. They're changing the sign. If it bounces off the x-axis, that's like a minus minus or a plus plus. Okay? So they're all sign changers.
Should we be worried about, like, when you say find the zeros, if the s in zeros isn't in parentheses? Should we be, like, if we just get 1 0? Should we
No, don't read too much in that. Usually I do put like, I do put the parentheses s to allow for one answer or more. Yeah, and this one, they always just say zeros. They never put in parentheses. So I wouldn't even look at that and use that as a hint at all, but that's a very, very astute observation. So thank you. I like that. All right, thank you. Okay, so number 13, find the minimum value of the derivative of this. Now this test is very straightforward. There are no trick questions. If there's anything on the test that comes anywhere near a trick question, it would be this one right here. So I'm gonna put a nice little extra star next to 13, okay? It's not really a trick question, but I mean, I guess it could trip you up, so just be careful, okay? Here's the deal. If you see the word minimum, what does that mean in math?
Derivative.
However, it is the minimum of a derivative.
So you take the
Derivative.
second
You have to
derivative.
go to the second derivative instead, okay? That's the trick, okay? So, kind of a trick question. In number 11, what did we do? In number 11, we did the minimum of the original equation. But in 13, we're doing the minimum of the derivative. So, let's do this first. Y prime would be x squared plus 6x plus 10. Okay? Well, I guess I'll just set that equal to 0 because it says
No,
minimum.
why double prime?
Then you're going to come up during the test and go, Mr. Wade, you made a mistake. Okay? And I'll do that, okay? You made a mistake. This doesn't, there's nothing that multiplies to be 10 and adds to be 6. I have to use the quadratic formula? Wrong step, buddy, except for I won't say that. Okay? I'll just say,
And then I'll.
can't go on time. Okay? So, this is the dir right here. Okay? That's the dir. But I want to find the min of the dir. Okay? So I have to find, yes, right,
You
exactly.
have to find the derivative.
So let's find the next derivative, okay? Or for instance, what if I said, where is the 57th derivative have a minimum? Okay? Where does the 57th derivative have a minimum? You have to check the, okay, 58, because you just go one beyond, okay? Where is the 67th derivative increasing? Okay, check the, okay, the next one after that, right? So let's go to the next one. Okay? All right, so 2x plus 6. Okay, now we're in the right spot. Equals 0. By the way, when you do this problem, the original snake goes away. It's meaningless. We're only talking about the derivative of this problem, not this. This is kind of like your original function now. And this is kind of like your first
So when it
derivative.
says value, are we gonna plug it into the first derivative then?
Yes, true, because it's a value of the derivative.
So you don't go back to the original?
No, don't go back there, that's also a common mistake. If you go here, you deserve to get it right, but if you put it back up here, you get it wrong. So, yeah. So, okay, here's the
It's
scoop.
like logic problem.
If I'm looking for the minimum of the derivative, isn't the derivative a, what's this?
Slope.
Isn't this a, oh, the derivative is a concave parabola. And the minimum value would be how low does the parabola go?
Okay.
Which has nothing to do with the original snake. Everybody see that? So you're only talking about the parabola, okay? Let me cross that dir and put parabola. All right? That's what we're focusing on. All right, so when I do this, the only critical number is what? Negative 3. I take that, I put it on number 1. I label it y double prime, but I'm actually just doing a first derivative test in theory. And I plug in negative 1,000, I get negative. I plug in 100, I get positive. And if the double derivative is minus plus, then the first derivative is what? It's decreasing, increasing. Wow, we're so surprised. If you take the derivative of a parabola and do a derivative test, it's a down out. What a shocker. All right? So you see you're looking at this right here. So the minimum occurs at negative 3. Okay? Let the record show I'm going over to my fake test over
Oh,
here.
wait,
Hold on.
Value Y.
And that's right.
Value.
That's where it is. How low is it though, right? Lowest point on Earth, Pacific Ocean. No, sorry. We're looking for negative 36,000 feet. So, take negative 3, get the value of the derivative, so put it back into the derivative to get its value, right? And you're trying to look for that, it's a vertex is all this, right? So, that would be negative 3 squared plus 6 times negative 3 plus 10, which is positive 9 minus 18 plus 10, which is a grand total of 1. That's as low as it goes. So I guess this parabola must be hovering above the
X-axis.
x-axis, because it never goes to negative. The lowest it goes is 1, so it must be up here. It must be above the x-axis. Okay? And if you graph that, it is above the x-axis. Lowest number is down to 1 and back up. Okay? So just forget about the original function altogether, because this is no longer your original at all. This is your original.
And that's only when we go to the next
That's if it's a minimum of a derivative, yes.
Oh, of the derivative.
Yes, that's the only case. Just take a derivative, forget about this, and say, okay, let me restart the problem from right here. Okay? So that, it's a little tricky there. You can go off course. Oh my God.